Hi, my name is Jessica Hintzsche, and I'm doing a Ph.D. at the University of Queensland in coffee. I'm going to be building digital twins for the aquaculture industry. A digital twin is a simulation of an individual enterprise, so it is the simulated version of a farm. We build an exact replica of each individual enterprise on the computer, and then we plug in all of the genotypes actually found on farm. And then we use all of those genotypes to simulate how they might spawn, and then what their progeny will look like over generations. And then we throw the farm under different selection regimes, we use different technologies, and then we can implement any new management strategies that they might be interested in. The advantages of using a digital twin is that the farm can try a new technology before they buy. So based on the fish that they currently have on their farm, they can see what kind of gains they will get when they try different management strategies, when they try implementing, let's say, genomic selection. They can really see what kind of gains they would get, and then they can weigh that against the cost of actually implementing these technologies. Digital twins are actually a bit new, but they've only been implemented in terrestrial systems. So we have one in cows, we have one in sugarcane, and we have one in wheat, but no one has actually tried to do this in aquaculture yet. The aquaculture industry is actually quite far behind terrestrial systems. It's predicted that just over 10% of all animals being produced are descended from genetically improved ones. So we need to really be bringing genetics into the aquaculture industry, and digital twins is a way of trying to figure out the best strategy for implementing these genetic technologies. What is going to be the best option for each individual farm instead of just making this broad one-size-fits-all model. So the CRC for the development of Northern Australia estimates that aquaculture is approximately worth $223 million, but by 2030, it's going to be worth $1.3 billion. So I really think that digital twins are going to be very, very useful in trying to help industry get to those gains. One of the reasons why aquaculture is lagging behind terrestrial systems is that, let's say, a SNP chip, so a way of taking a sample of the full genomic sequence to kind of try to estimate what alleles might be present in an individual. Each one of those is going to cost $30. So $30 per one individual. So for the dairy industry, let's say, one animal might be worth $4,000. So it's pretty easy to justify that $30 genotyping expense. However, for the prawn industry, each individual might be worth less than $1. So that $30 genotyping fee could be hard to justify if you didn't know how it was going to turn out. So that is what is so useful about digital twins, is that you can run those simulations. I'm going to be working with Mainstream Aquaculture, a barramundi farm based out of Werribee, Victoria, but they have farms all over the country. They have progressed to their genomic prediction stage of their farm, and they want to know what is going to be the best approach to genomic selection that will really optimize the gains seen at their farm. So they're actually going to be the first digital twin in the aquaculture industry. As a scientist, these are the moments you really live for, is being able to translate what you do in the lab or on the computer directly to industry and be able to see the impact and outcomes of your research actually help somebody.